Welcome back to the second video of 2 about tramming my little Proxxon milling machine. In the first video we tweaked the Z-axis so it would be as perpendicular as possible to the table. Card here, link in the description. In last week's video we made this little shaft here so I can attach my dial gauge here to the actual spindle motor. Also card here, link in the description. So in this video we will do the actual classic tramming of the spindle axis to the table. So getting the spindle axis now perpendicular to the table. Enjoy! This is Robert from the future. After I finished tramming that thing. This will not be a straightforward tramming tutorial because I ran into different problems here while I was tramming. Most noteworthy, the run out of my spindle itself, which made tramming more like a statistical thing than straightforward. Turn your dial around your tramming plate and adjust, in my case, shim the clamp for the spindle a little bit. And I'm still a little in incoherent through the whole video. So if you're looking for just tramming 101, this video is not for you. There are better videos for that on YouTube. And now, enjoy or not. Now, that little lathe has absolutely no adjustments when it comes to the angle here of the spindle when it's mounted to the Z-axis. We already adjusted the Z-axis stuff, so it will be perpendicular or is as perpendicular as possible to the table. So everything we do now will be based on shimming here around the clamp and the actual spindle. And the first thing you should notice here, which makes things very complicated, is when I actually clamp the spindle in here, and please watch at that gap here. The whole thing, it tilts a little. But anyway, let's clamp that in and measure actually the how bad it's trammed now. Before we start with the actual tramming, it would be a good idea to measure the actual run out of our spindle and our shaft here we made in the previous video, just to be on the safe side. So the run out. Oh, that's bad, Muriel. That's very, very, very bad. Okay, the question is that my spindle itself or is it my shaft? There's a way to find that out. Just give me a second. Okay, I blocked the spindle by inserting here a little key, so the spindle is no longer turning, and I loosened that nut a little bit, just a little bit. It's all still very stiff and tight here, but now I can with some force turn my shaft here without the spindle turning, and you see the shaft is all right. I can turn the shaft. The shaft itself doesn't have any run out, but my spindle has quite the run out, or developed during the time I was using it, quite the run out. There's nothing I can do about it now, but that means when we are tramming the whole thing, the alignment, we will just turn the shaft here and not the spindle. It's not ideal, but it's all I can do right now. Problems. And when we trend in one direction, we will actually have to grab this here, turn the spindle axis 45 degrees, and then we will repeat the tramming and see how big of an error we get. Am I in frame with the hand? Doesn't matter. As I mentioned, not really ideal, but there's nothing I can do about it right now. I attach the dial gauge now here to the shaft so we can rotate it freely around the table. There's only one component missing now for the tramming. And that is some kind of a precision plate. This is a precision milled aluminum plate. It was featured in a mailbag card here. Link in the description. So we can freely rotate that without getting hung up on all the nooks and holes in the table itself. And I should also mention that dial gauges for tramming are usually fixed here and the lower part is rotating, so you always see the dial face. I don't have that luxury, so I will have to turn the whole machine so we can always see the face and where we are at. Okay, let's start. This will be a little bit cumbersome, so we are here now approximately at 0 at the front, and I'm trying to rotate now to the side, and I'm rotating with the spindle, okay? So the spindle is not locked. Oh, that's not too bad. Okay, now we're going to the back and it gets bad. You probably won't see it. Oh, 25 hundredths. Okay, it was 30 hundredths below the column. Am I still in the picture? Is that still in focus? Yeah, it is. 45 hundredths, and then when we come to the front again, it should return slowly but surely to 0. Yeah, but yeah, it's terrible. It's terrible. Now we talked about that I have quite a run out here, so let's try that with the spindle axis locked again, and I'm just turning here the shaft inside the collet, yeah, with a little bit of friction, or well, a lot of friction in fact. I marked the 0 again. Here we are at the front, and I will try to speed that up now by rotating here. So, okay, we are already 40 up. Ooh. And now for the back, that's a little bit hard for you to see because of the column, but yeah, let's try anyway. Still 40. Well, it's actually 30. Sorry. A little over 30. And then as we come full way around, we're coming close to 0 again. And we should be at 0 when we're back at the front. Oh, not quite. Yeah, this is BS. But there's really nothing I can do about it. But at least we see how that trimming stuff works. Okay. Now obviously we are on the back. We get closer to the table. So the axis is misaligned in that direction. So we were higher at the front and lower at the back. But I told you we had quite the run out here in the spindle itself. So we will turn the actual spindle axle shaft just 45 degrees. And we repeat that measurement. Set to 0 again and 90 degrees. What will happen? Oh, we're coming up quite a bit here. No, we're going down. We're going down. Hoo-hoo. Yeah, that's the problem with the run out. Now we're down at the back 30. Yeah, can you read that? Still 30 at the back, aboutish. And then we come back again. Oh, this is a total mess. I don't know what to say. This is total and utterly BS. This is quite a run out I have here. Okay, you understood the principle of tramming, I hope. Yeah, I can't really do a video about this. I'm sorry. Let me fumble around with that thing and some shimming, and maybe I can at least show you that I was able to improve things. Yeah, sorry for that. Okay, here's what I did. I made quite a few turns here, measuring the arrow on the front, left, right, and back, and this was not the only page I've written with the arrows, and tried to do a little bit of a statistical method of just minimizing the total error. And I ended up shimming here a little bit in the front with an 0.1 millimeter aluminum sheet, just really a sliver really going down here into the clamp. And I think I can't really do better without rebuilding the whole spindle. Let's have a look at the results. I'm at the front now at 0. At the left at -10. At the back at +2. And at the right at +10. So, yeah, not ideal, but that's all I can get out. Yeah, front 0 again. That's all I can get out of that thing at the moment. And that's down from an error of -80. I think I measured that at the back. Front was always 0 in the beginning. So, yeah, an improvement, but I'm not so happy with it, but it will have to do. And just as a sanity check, the spindle is locked now. And I'm turning my whole assembly here 45 degrees. And then we do the whole measurement again. So front 0. On the left we got, oh, -8, not too shabby. And at the back we are at +4. +4. Can you read that? It's +4. And at the right, yeah, +12. And hopefully at the front, back to 0 again. So all in all, let's say a total error, let me zoom out, of 0.1 millimeters at a radius of 10 centimeters. Now, when you only have here something, let's say a tool that's 20 millimeters in diameter, so a radius of 1 centimeter, that error reduces to 100th. And yeah, we will see in practice how accurate that kind of trimming really was. Tramming, not trimming. Yeah, I'm little disappointed with the runoff of my spindle here. That's it for today. Well, not really, picture book tramming tutorial. I thought I would make a cut together sanitized version, but I really wanted to show you what problems you can run into with such a small machine and how you can overcome them with lots of patience and lots of twiddling around. Till next time, bye.